In the previous problem, we have discussed step 6 till step 6. So in that step 7 is we have to find out angle of departure. Why? Because there are poles are there, complex poles are there. The complex pole is minus 3 plus J4 and minus 3 minus J4. We'll consider only one complex pole, minus 3 minus J4. So that is, see, for the given problem, one pole is at 0, one pole is at minus 2, and one pole is at minus 3 plus J4, and one pole is at minus 3 minus J4. Now, to find out angle of departure, we'll consider one pole, okay, one pole, that is minus 3 minus plus J4. So to find out this angle of departure, we have to join all the other poles. Okay, we have to join all the other poles to this particular pole. So we have joined all the other poles, and also we have to join actually other zeros also, but zeros are not there in this problem. So only poles. So we'll find out the angles 5p1, 5p2, and 5p3. So 5p3 is by assumption I can say it is 90 degree. 5p2 and 5p1 we have to measure. So we'll get 5p1 is 126.86 and 5p3 is 104.03. 5p2, okay, 5p3 is 90 degree. And we know the formula for angle of departure is 180 degree minus phi. And here phi is summation 5p minus summation phi z. Summation phi p is we have to add all these angles. Okay, it is 320.89 degree. You will get summation phi z is 0 degree. If you substitute here, we'll get 320.89 degree. So then if you substitute 180 degree minus phi in the value of phi, if you substitute 320.89 degree, we'll get minus 140.89 degree. So the meaning is angle of departure is equal is minus 140 degree point 8 140.89 degree at minus 3 plus J4. For this pole we will go to this angle, and for another pole, that is minus 3 minus J4, we have to no need to find out, we have to write uh, so we have to write plus 140.89 degree. Okay, so we have to change the sign, that's it. So now we have to write the complete root locus by using all this, by considering all these steps. So that is, see in the given problem, so this is real axis and imaginary axis, and see pole at 0 we know, and a pole at minus 2 we have to sign by using multiplication sign we have to mark, and another pole is at minus 3 plus j4, that is here you will get, and another pole is minus 3 minus j4, so by using multiplication sign, and we have calculated a breakaway centroid, so that is minus 2. Just to go through the steps, and we got to minus 2 centroid, and it is properly by using scale it is marked here minus 2, and four angles we got, that is theta 1, theta 2, and theta 3, and theta 4. So we have to write those angles properly, we have to write like this, we have to measure, and we have to write angles, and these angles we have to find out, and we have to write. Now, so next we have to find out, we have to write, we have to mark a breakaway point. See, breakaway point is the point minus zero point 0.9 we got. Okay, so mark here properly, mark breakaway point, that is on root locus branches. Okay, or yeah, root locus branches between two poles. So you have to mark. Afterwards we have to by using, and the intersection point on real axis also we have to mark. So that is we got by using the last step, we got plus j 2.5 and minus j 2.5 intersection point on imaginary axis. By using proper scale we have to point, we have to mark that one. Then afterwards, by using freehand, we have to draw root locus branches from this point, breakaway point, and by using freehand, we have to draw, and it should cross this imaginary, the point intersection point on imaginary axis, and then afterwards it has to go along with this asymptote till infinity. So it should go parallelly, okay, till infinity. Here also it has to cross mm, intersection point on the imaginary axis, then it should go along with the asymptote, and it should not like meet this asymptote, it should go parallelly. Okay, it should go parallelly till infinity. And next, see, angle of departure we have to mark. See, angle of departure is we see at one complex pole we have to mark, that is we got angle of departure is minus 140.89 degree. So for this point we have to mark minus 124, that is this angle you will get, this angle, this is a minus 140.89 degree we will get. So the thing is, by using freehand we have to draw that in this direction, we have to draw the breakaway point from this angle of departure, and then afterwards it has to go along with this asymptote parallelly, it has to go till infinity. So that is the concept, that's why we are going to use this one, angle of departure. So that is, see, angle is minus 140.89 degree. So we have marked that one, and this is the angle we will get. Then by using freehand we have to draw along with this angle, afterwards it has to take deviation, so because it has to go along with this asymptote till infinity. So here also for another pole we got plus 140.89 degree, we have just changed the sign. Okay, so plus 140, so like this we have to mark. So this is the angle we will get, this angle. And now by using freehand we have to draw this asymptote, no, root locus from this point. So and it has to go along with this asymptote angle, okay, till infinity. So in this way we have to draw, we have to construct a root locus. Next, we have to give a statement about stability. Stability is not asked. So, if you want to discuss about stability, then it should be stable. See, by using root theory, we know that the first column should be positive. So, when it will be positive, if this value s to the power 1 row, so here k is there. You see, s to the power 0, k should be greater than 0, right? And here s to the power 1, k marginal we have calculated, it is 192.1875. If we substitute this k marginal here, we will get 0. So that means, so till that point 192, it should not equal or it should not greater than this point. Then we will get negative value or 0. So I can write the stability, for stability of this system, the value of k should be greater than 0 and less than 192.1875. If it is less than 192.1875 k value, then we'll get here positive value. Then by using this root theory, first column will be positive only, no sign changes, the system will be stable. So thank you.